Hello, sir.
Yeah, yes, madam.
Sir, 87 participants are there. Shall we start or we'll wait for 5 minutes?
Uh, shall we wait for 2 to 3 minutes?
Okay, sir.
Madam, shall we start? I think
Yes,
it's
sir.
exactly 11.
Yes, 120 participants are there. We'll start, sir.
Uh, I think people will be joining in another 5 minutes. So we can start, I think.
Okay, sir. Okay. Welcome to day 2 online FDP on machine learning and deep learning. Once again, I welcome our eminent speaker, Dr.D.Jude Hemanth. Welcome you, sir, and all the participants for today's session.
Thank
I,
you.
requ- I request all the participants to subscribe our channel. I think only few have subscribed. Please do subscribe. And the attendance link will be given in the chat box at 11:45 a.m. and it will be closed at the end of the session. So I will give the assignment link at the end of the session. You have an option to upload your assignment in the Google form. Kindly go through it. The session may exceed 15 to 20 minutes. That's based on the question session. Kindly bear with us. If you want to interact with Sir, ping me in WhatsApp. So now I hand over the session to Dr. Jude Hemanth. So please.
Yeah. Thank you, madam. And thank you, participants, for joining on time today morning also. And the timing is very, very important because when the participants join late, we are supposed to postpone our session also by 5 to 10 minutes. which will finally affect the question answer session. Right? I would like to say that question answer session is a forum where you can share your queries for which you can find the answers. Right. So now we'll go to the day two. Before going into day two, I would like to give a small summary of what we saw in day one. I understand there are few new entrants also. So day one completely belongs to beginners, right? I gave you a complete overall view of what is happening in AI. Without knowing those details, if you go into the subsequent sessions, I'm sure that your understanding will not be that good. So what we saw yesterday, the three classifications. AI is the broader umbrella under which we have the concepts of machine learning. There are many ways by which you can give an intelligence to a machine. One method is machine learning. In machine learning, there are so many algorithms and techniques. One of them is artificial neural networks. After artificial neural networks, the advanced form of artificial neural networks is deep learning. So we are going to see from the first till the last AI, ML, artificial neural networks, and deep learning. So yesterday we had an overall view about ML. So now we are going into the concept of artificial neural networks. Yesterday, I also touched a bit about artificial neural networks, why we go for artificial neural networks, the necessity for ANN, right? When you study something, you must always understand why you go for studying that specific concept or subject. If you do not have a deeper understanding, building on the advanced topics is going to be very, very, very tough, right? That's why I concentrate both on the theoretical aspects and mathematical aspects, which I will be dealing a bit today. So today's day will be both for beginners and the intermediate people. So now we'll go into the agenda of today's session. So the first agenda is converting a natural brain into artificial brain. So last class, last session, we saw about how a natural brain functions, what are the characteristic features. Now, after studying that, I want to convert that natural brain into artificial brain. I need a structure and at the same time, a functionality for the artificial brain. Second, I will go into the technical aspects of ANN. I have chosen two artificial neural networks. The first one is the back propagation neural network, right? The reason why I have chosen this is the base on which deep learning is built, right? Without knowing stochastic gradient descent algorithm, or in other words, back propagation neural network algorithm, it is impossible to go into the concept of deep learning. That's why I have chosen this. Again, this is a supervised. We saw the categories of artificial neural networks last session, and based on the structure, based on the algorithm, right? We have a supervised, unsupervised algorithm. We have the single layer, multi-layer network. So this BPN comes under the category of multi-layer and supervised algorithm. To give you a better understanding, I have also chosen another approach which comes under the category of single layer unsupervised. So I could cover all possible options of ANN within these two neural networks. Don't think we have only two neural networks. We have n number of artificial neural networks. But if you are able to understand thoroughly, even if you have a full stop in any one of these, you must know why you are keeping that full stop. If you are in that level, then automatically you can build on the advanced topics. That's why I have chosen these two. And then we will have, as usual, the question answer session. So today, last session, we saw completely a theoretical concept, and today we will be having both theory and mathematics. So prepare your mind for a bit of mathematics also. So now we'll go into the process of converting a human brain into an artificial brain, or in other words, I would say converting a natural brain into artificial brain, right? Or in other words, I will say a natural neural network into artificial neural network. So when you look at the structure of a human brain, right, this is how a human brain looks like, right? We are not doctors. We need not go into the medulla oblongata, cerebrum, those concepts. We need the functional principle of human brain. But structure-wise, a brain looks like this, which is very, very complex to reproduce. So human brain is made up of 10 power 11 neurons. right? So when the scientists or the researchers came to know that brain is made up of neurons, instead of finding the structural view of brain, they are more concentrated on the structure and the functions of neurons, right? That is the innermost element or the atom of any human brain. So if we are able to replicate the structure and the function of a single neuron, you can connect many neurons to form a neural network. And because it is made by you, we can call it as an artificial neural network. So even if I say I'm going to replicate human brain, to be precise, I'm going to replicate the neurons, each connected to 10 power 4 others. These numbers are only to show how complexity our human brain is. Can we replicate the same complexity in our artificial neural networks also? Very, very tough question. And the speed, right? When you take a decision, as I told you in the previous session, the decision making skill is very, very important. And the speed with which you take a decision is very quick, right? When you say switching time, it is 10 power minus 3 seconds, but the computer switching time is 10 power minus 10 seconds. It depends, right? The quickness which we have in the human brain and the computer, can we get that in an artificial neural network? That is also very, very important. This is a research problem which you have to note down in your scribbling pad. Attacking the computational complexity of artificial neural networks. This problem till now remains unexplored, right? This is a challenge for the experts or the intermediate people who can work on that. So again, it's a human face, an example, highly parallel and distributed process. Last session, I told you when I asked you about the difference between brain and computer in terms of speed, right? I stressed on the necessity for parallel computing. Nowadays, when you look at the systems, this NVIDIA or with the GPU, we have the facility for doing parallel computing, but still quicker. Can we make some artificial neural networks? That is one of the most important research problems. Now we will see how we are going to convert a human brain into artificial brain. For that, I am going to show you the structure of neural network. This is an internal view of human brain, right? The previous diagram is an external view of human brain, and this is the internal diagram of human brain where you can see the dark shades like structures. Those are the actual neurons, right? Because it is connected to all the other neurons, we call it as a neural network, right? People will really struggle to understand or to visualize what is happening in this neural network. How we are going to replicate this is a very, very challenging process. So you can see in this simple screenshot itself, you have n number of neurons. So for better understanding, what we are going to do is we are going to take only two neurons, right? The circles represent, which is represented in the figure, shows two neurons. One is on my left side and the other is on my right side, right? So, but remember that you have a large number of neurons connected with each other in the brain. Now we will see what happens between these neurons. Even if two neurons are connected, we can call it as a neural network, right? So first we will see what happens within a single neuron, how the information is transmitted to another neuron, and how a neural network will work. Once if you understand these things, then immediately we can go for having a analogy process for our artificial neural. Right? These understandings are very, very important to build on advanced topics. So you take one simple neuron, right? Only one circle. The four parts which we have here, which I can say is dendrites, another one is soma, another one is axon, right? So these are the three important parts of a neuron. So when you create an artificial neural network, which consists of artificial neurons, you also must have dendrites, axon, and soma, not in terms of blood and flesh, but in terms of steel and iron. What does these dendrites do? These dendrites are acting as inputs for the neuron, or we can say inputs for the human brain, right? How many dendrites you have? When you see the diagram, you have more dendrites. That's why I told you the human brain is going to be completely parallel in nature. It can accept many inputs at a time, right? All these branches shows that inputs from different sense organs will reach your human neuron. Right? So these are the dendrites which carries the inputs to the center of your neuron. The second part, which we call it as soma or cell body. See, artificial intelligence is a mixture of computer science, mathematics, and biology. If you mix these three things and make a product, the resultant is artificial intelligence or machine intelligence. So when you look at your soma or cell body, this circle corresponds to the central part where all the inputs are taken and given to this neuron. So this cell body is responsible for carrying out the some operations for necessary for decision making. The two maximum used operations in the human brain are computational operations and logical operations. Right? You can think about any other operations, but it will come under only these two categories. What is computational operation? If I ask you what is 2 plus 3, you will immediately give me an answer of 5. Right? Any answer or any question for which a response in terms of number, then we can say it as a computational operation. Right? My next question is, will it rain today in your place? Right? Will it rain today in your place? Now, based on the past data or based on the current temperature, you are going to take a decision that whether it is going to rain or not. Right? That type of linguistic or expressions which does not have a mathematical number comes under the category of logical operations. Right? So these logical and computational operations which is carried out in the cell body should be also carried out in our artificial neural network. Right? Once the soma takes determines the output, right? It gives it into the axon. All the human brains are made up of chemical reactions and electrical reactions, right? This soma gives an output in the form of an electrical signal which reaches the axon. The axon is the output part of the neuron from which different instructions are carried out to the different parts of the body to take a decision. Right? Suppose I can give you an example. Suppose if a snake enters my room, right? Don't get scared. If a snake enters my room or your room, what will happen? Immediately we start running or try to find a place where we can have a shelter, right? What happens within this point? You have a dendrites, right? Dendrites receives the inputs from our sense organs. So eye is capturing all the input data, right? Even though we have five sense organs, when we see a snake, that is mostly going to affect our human brain. It takes to the cell body. In the cell body, we have two operations, computational or logical operations. But in this case, no computational operation, but logical operation takes place. So with this logical operation, you come to know that snake is going to be dangerous. How you know that snake is going to be dangerous? How your brain tells you that snake is going to be dangerous? Because you have already seen a snake or already heard about a snake. Then you come to know the snake is more dangerous. And that instruction is given to the axon or the output terminal of the neuron. To which part of the body? Immediately to the legs. So you start. This is what happens in a single neuron. Right? But a single neuron is not responsible for the complete operation of a decision making skill by the human beings. A group of neurons, that's why we say natural neural networks are responsible for the process or function of a simple decision making skill. Now, this input or data is given to the next neuron via an position called a synapse. The synapse is the fourth part of the neural network. This synapse is very much responsible for passing the information from one neuron to next neuron. So when you have some old people, grandmother or someone in your home, right? Whenever you call them or ask them anything, immediately they may not respond. The problem is one neuron may be working, but that information may not be carried to a next neuron so that the entire operation or decision making of turning the face will be carried out. Right? So it depends upon the strength and the weakness of the synapse, axon, and soma, and many other issues. All these issues to be taken care when you create an artificial neural network also. This synapse actually releases two chemicals. One is called as an inhibitory chemical and the other one is called as excitatory chemicals. Right? Inhibitory chemical is used for stopping an operation. So please make a note of this in your scribbling pad. This is what is crucial when you go for your artificial neural networks. Synapse is releasing an inhibitory chemical which is used for stopping an operation, and the other one is going to release an excitatory chemical which is going to initiate an operation. Say, for example, you are running from the snake, then you are keep on running, right? In before you, you are suddenly seeing a well, a huge well. What you will do? You will take deviation and go, right? So when again you reaches the well, immediately again your eye captures the picture of a well, gives via dendrites to the cell body, where it says getting caught by a snake is also same, which is equivalent to falling inside the well. It is dangerous. So immediately you take a decision, stop or pausing for a small moment. That process is done by these inhibitory chemicals released by synapse, right? Then you take a deviation, then immediately excitatory chemicals will be released, and then you will keep on. This is what happens inside the neural network or human brain whenever you go for a decision making approach or a decision making skill, right? So, in other words, I can say dendrites are inputs, axon is output, and soma is the processor when you compare it with a computer, right? And these synaptic junctions can have excitatory or inhibitory processor. Either it can stop an input or it can initiate an input. Activation potential is the electrical signal which is transmitted from the soma to the axon. As I told you, nothing will be in terms of numbers. Only computers works in numbers. But human body is made up of blood and flesh, where we can find some electrical signals, which we call it as activation potential. I am not going to much depth about the activation potentials. If you want, you can look at any biomedical or biology books. But these are important concepts to convert it into an artificial neuron. Transmission of signals will be had stimuli from the environment to the effector, from the input to the output. So now, how we are going to convert a human neurons to artificial neurons? This is what you will see in all the textbooks, right? On my left hand side, I have my natural neural network. On my right hand side, I have my artificial neural network. Each circle, each neuron is represented by a circle or a box, right? So some books you will be having a circle, or some books you will be having a square box. Both are going to be same. A column-wise arrangement of neurons is called as a layer. This is where God's creation and human beings' creation differs. Look at my left-hand side picture. Can you get some pattern out of the arrangement of neurons? Definitely not. It is completely random in nature. The scientists, even though they are trying to replicate the operations of the natural neurons, they find it very difficult to replicate the structure of the neurons, right? That's why, for easier understanding, they are arranging everything in the form of one below the other, right? Where we say it is a column. So one box corresponds to one neuron. So all the six boxes corresponds to six neurons. And the entire six neurons is called as a layer, right? If you do not understand the concept of layer, you will not be able to understand the concept of deep learning. Each neuron in one layer is connected to all the neurons in the next layer. Underline the word only. If you look at your artificial neural network, the first layer, right? How many layers do we have here? Three, right? Three layers we have, but the first layer neuron is not connected to the last layer neuron, right? Why? You to avoid more complexity. But that is not the case when you go for your natural neural network. We have sufficient connections in your human brain, which is not exactly possible to replicate when you go for your artificial structure. So these are the 2 points which are completely different from natural neural network to artificial neural network. And another point is an ANN can have any number of layers, right? Artificial neural network can have any number of layers. How many layers do I have here? I have 3 layers here, but if you want to go for 5 layers, 6 layers, 10 layers, it's very good. Deep learning has even 1,000 layers, right? That's why ANN is very, very important. The first layer is always called as input layer. There is no change in that, right? Whatever may be the neural network, the first layer is going to be always an input layer. The last layer is always called as an output layer because this input layer is equivalent to the input structure of our natural neural network, and output layer corresponds to the output structure of our artificial neural, where we are going to make a decision, inputs and a final decision. In between that input layer and output layer, we have n number of layers, or you can say you can have n number of layers. The minimum possible layer you can have is one if it is a multi-layer network. Do you remember the diagrams which I showed you in the last session? And when you go for your single layer network, you will have only input layer and output layer. Now you can correlate with that. When you go for your multi-layer networks, you can have input layer, output layer, and between that, you can have n number of layers. Each layer is going to be called as hidden layer. The meaning for hidden layer is because it is hidden from the data transfer of the other inputs and output layer. You cannot see the from the left hand side or the right hand side the concepts of hidden layer. That's why we say it is a hidden layer. Some people say it is also a middle layer. Anything is okay. So this is the structure you must know. Look at the interconnections. Each neuron from one layer will be connected to all the neurons in the next layer. Right? This is very, very important for understanding. Similarly, the neuron connection from the first neuron in the second layer is also connected to all the neurons in the next layer. So now we will see what happens within this box, right? What happens within this box, right? Now these lines corresponds to dendrites. The interconnection lines corresponds to dendrites in the human neuron, right? And the box is the place which corresponds to the cell body where we are going to make any computational or logical operations. And the next line, it corresponds to axon. From the axon, what happens? The data is taken and given to the neurons of the next layer. So again, you have boxes, right? Again, you have connections. Some operation is going on inside the box. And this process continues till the end of your layers. Now we will see what happens within each box, right? I have given in the form of a circle for better understanding. But if you draw a box, that is also fine. Now, slowly we are going to transfer our theoretical concepts into mathematical concepts, right? So when you go for your application or programming, you will not have a raw data. You will have data only in the form of inputs, x1, x2, x3, xn minus 1, xn, right? That means you can have as many inputs as you like. There is no restriction for the number of inputs. Like how human brains take many inputs at a time, your neural network also can have many inputs at a time. Now these X are the inputs which are given via the lines. You forget about W now. It is given via many lines, the dendrites, and the round corresponds to the cell body. What happens in the cell body? What is the analogous operation of computational and logical operations in terms of mathematics, right? We are having two operations in the cell body, right? The first function, we are going to have a parameter called as net value calculation, right? Net value calculation. This net value calculation is denoted by a parameter called as z. I'm giving a value as z. Now you look at the equation within the circle, you will find z is equal to summation of w into x, right? So the first step whenever you go for programming, right, or implementation is you need to find the net value of the first stage of your neural network, right? How will you find the net value? Z is equal to summation of w into x. Do you know x? X. X is your inputs. Depending upon your application, you will have your inputs x. Now, what is this w? This is very, very important aspect, right? I will tell you later. Now, once you know the w, you can find W into X and S. If you want to expand this expression, you will have Z is equal to W1 X1 plus W2 X2 and so on. After finding Z, you are going to have a value called as output value, which is the actual output of that stage, right? Which I'm going to pass it through an activation function. H corresponds to an activation function. This activation function is not much seen in natural neural network, right? We have incorporated this additionally because we have a drawback in all our computing systems, right? I will tell you, right? This function is something like compressing the dynamic range of your inputs, right? H corresponds to activation function, which compresses the dynamic range of your inputs. What do you mean by dynamic range? Say, for example, I have an input which ranges from 0 to 255. But the capacity of the computer or the machine which I'm working on cannot hold up to a three-digit number. It can hold up to one only. What should I do? The 0 to 255 should be completely translated to something of sort 0 to 1. How can I do that? Normalization is one of the best example, right? You take any number from 0 to 255 and divide it by the maximum number. 0 divided by 255 is 0. 255 divided by 255 is 1. So all the numbers between them will be converted into a value 0 to 1. This is one way of compressing the dynamic range of the inputs, right? So whenever you have a large data application and if your computer is not able to make sure that it cannot hold the data, then we purposely inbuilt the activation function within our system, right? So most of the neural networks will have this concept of activation function so that your processing, your complexity, everything will be benefited, right? So the final output is Y. This is a single neuron's output. If you want to see your diagram, this is one single neuron's output. Next, what happens? This output will be taken as input. Likewise, we will have many outputs. These outputs will be taken as inputs, carried over to the next stage, and the process will continue. All these process can be accomplished only if you know what is this W, right? This W corresponds to a parameter called as weights, right? This
Sir,
is what people normally miss when. Yes, madam.
sir, sorry to say interrupt. Sir,
Yeah, yeah.
at the bottom of that PPT, please hide that. Click that hides. It is not
Is it okay
visible.
now?
Okay, sir. Okay, sir.
Is it okay?
Okay,
Okay,
sir.
right. So, uh, these weights are very, very important parameter when you go for your artificial neural network. So, what is this weight? Right? We have so many inputs, right? But you must know that all the inputs are not necessary for the operation of my neuron. Do you agree with that? Right? Now you will take your situation, right? You are looking at the screen, you are listening to my voice, and there may be other inputs also surrounding your environment that also enters your brain. But what happens is you are going to give importance only to those inputs which are extremely valuable in your eyes or for your application, right? So W1, W2, W3, W1, all these weight values will have a range of values from 0 to 1, right? If I assign a value of 0, that means that input is not important and that input will not be taken into account when I go for calculation. How? Z is equal to summation of Wi into Xi. If I have two inputs, W1 X1 plus W2 X2. If my W1 is 0, W1 into X1 is going to be 0. So 0 plus something is that effect of input will not be there in my neural network, right? So this concept of weight is where we are going to make use of our artificial neural network to train. Weights are important measures which decide how much an important an input is, but you will not be knowing whether an input is important or not in the initial stage. We are going to train our network and finally we are going to decide how important an input. is, right? So with the help of random initialization of weights, you can find your net value and you can find your output value, right? When you go into a training algorithm, I will teach you how you are going to adjust these weights so that random weight values will be changed into your correct weight value, right? So these are the operations. I hope you are clear about the operations going on inside the simple neuron. Two operations: net value calculation and output value calculation. But remember, these operations will not take place in the first layer or the input layer. Please scribble this in your notepad. Right? Input layer, hidden layer, and output layer. All the operations are going to take place only from the second layer or from the hidden layer. Input layer function is only to distribute your data to the subsequent layers. Right? You got an idea how a neural network or is going to function? So you need to frame the architecture, then you must know about the function. Now you may have a question, right? How many hidden layers in ANN should I have? This is a research problem number one, which I am throwing at you, right? Till now, there is no concrete evidence or justification to say that you need to have these many layers for application. We are going to randomly select the number of hidden layers, right? Till now, the problem exists. Few people are working on that. Hopefully, we will get a new solution, or one of you sitting and listening to this lecture can find a solution for that. Research problem number two, right? How many neurons in your hidden layers? I showed you some boxes, right? But how many neurons in your hidden layers? That also till now remains a mystery. Nobody is able to fix down what should be the exact linear relation between the first layer and the hidden layer. How many neurons should you have in your input layer? Any guess? If you understand this operation, then you must be in a position to tell. What is this? Inputs, right? One input is given to one line. That means each boxes in the input layer can transmit one input. In other words, the number of neurons in your input layer depends on the number of inputs you have. Understood? Right? Next, the number of neurons in the output layer depends upon the number of classes. If you go for a classification problem, how many classes you have, right? Based on the number of classes, you can have number of neurons in your output. But till now, there is no idea or understanding of how many neurons should be kept for a hidden layer. One time it works, one time it will not work. If possible, you can find a solution for that. And I'm throwing you an advanced research problem. There may be some experts sitting in this workshop or FDP, right? My question is how net and activation function resembles the operation inside soma. I told you blindly. People say that neural networks is a black box. What is a black box? We will not be knowing what happens inside that, right? So what I have told you, net value calculation and output value calculation, a summation, a multiplication, and passing through an activation function. These three steps are responsible for the operation taking place inside the cell body or soma. How? Can you have a justification? Can you have a verification? If you can find this one, it will be an excellent output for the research community of artificial neural networks, right? That is an advanced research problem. I do not want people who are starting or in a 50% of the stage need to explore this. Only if you have a thorough understanding of what happens inside, you can explore that, right? So if possible, you can try working on it. Now, to summarize the conversion from human neurons to artificial neurons, you can look at this diagram. Soma is nothing but your neuron, right? The circle or the box. Dendrites are nothing but the inputs. Axon is nothing but the output. Synapse is the thing which is going to either release excitatory or inhibitory outputs, either to stop or to start, right? Zero or one. Weight, right? Among these four, this weight is going to judge how you are going to make a decision, right? Some people who takes more alcohol, right? They will not be able to control themselves. They just walk on the roads. Why? Their inhibitory chemicals will not be released, right? That's a chemical called as gamma aminobutyric acid. I'm not going into details of that. That will not be released. So they are not able to control themselves, right? So if you want to have an input to be suppressed, you need to assign a weight value of 0. If you are not able to assign a weight value of 0, your training process will go wrong. Your decision making will go wrong. So everything is focused around the concept of weights, right? So this is your diagram: input layer, middle layer, or hidden layer. Or I'm giving you different combinations, right? Middle layer or hidden layer or output. Understood? This is the methodology how we are going to transfer from artificial natural neurons to artificial neural network. Or so hereafter, I'm going to put aside the biological concepts and we are going to see only about the technical concepts of artificial neural network. At this point, I want or I have an understanding that you know what is this interconnection, what is this box, everything. Because based on this, I am going to explain the algorithms further. This is one application where you can have some light temperature, humidity, environmental setup, and then you can say whether it belongs to transpiration, what is the value of transpiration, what is the value of assimilation and allocation. Likewise, your application will vary. So now we come into an important part of the second part of artificial neural network. As I told you, the first part is framing a structure. So whenever you are going to work in artificial neural network for your application, you take a paper, you take a pen, draw an architecture. Right now, you know what is meant by single layer. You know what is meant by multi-layer. How many neurons you should have. Everything you know. Draw an architecture, a rough structure. Right. Once you draw a rough structure, next you need something to make it function. It's like a doll. Only when you give a key, it will start functioning. That key is nothing but the concept of training. So the second thing you will need is training. What is meant by training? Training, learning. As I told you, whenever a new data is given to a human brain, we store in that. So training is the processing of storing the input data within it. Within what? Within our artificial neural network. How do you store? Right, that is what is an important part of a programmer or an engineer or a researcher who is going to implement that. Training, right, it is the process of adjusting the weights iteratively. Why iteratively? Do you remember the basic um, requirement for a machine learning approach? Machine learning approach is always, or at least I can say 99% iterative in nature, right? So it is the process of adjusting the weights iteratively. Why training is iterative? Because we cannot learn in a single day. Because we do not know what do you mean by learning. Learning is nothing but which inputs are important to you. Finding which inputs are important to you is the concept of learning, right? So that inputs importance is determined or available in the weights. So only if you are able to find out the correct set of weights, then we can say the network is trained. Till finding the correct set of weights, you need to keep on adjusting the weights iteratively. That complete procedure is called as training, or in other words, we can say it as training algorithm. Right. So what happens in each iteration? In each iteration, initially you have a random weights. What do you mean by random weights? You just randomly assign something. You do not know which input is important or which input is not important. Once if you know that, then there is no necessity for training. You understood the concept, right? So you have an initial random weights, and when you go for your approach, the weight changes in each state. When the weight does not change further, we say you have already learned everything. You have already learned everything. Say, for example, I'm showing you an apple, I'm showing you a mango, and I'm showing you a banana, right? For apple is one input, mango is one input, and banana is one input. Apple have a weight, banana have a weight, mango has a weight. But I do not know how I am going to treat them. So I keep on changing, neural network will keep on changing the weights. At one point of time, the weights will not change further. The value of 0 to 1 will not change further. Then I will understand that when I show an image of a banana to my artificial neural network, it will be able to identify that it is a banana. Or otherwise, I can say the data is stored in the brain. How we see Taj Mahal and store the data. Similarly, the data will be stored in artificial neural network. Each ANN has its own predefined training algorithm. That's what we are going to see now. Now, the question is where the data is stored. Very, very interesting question. Only if you have a deeper understanding, you can tell the answer for this. Where the data is stored, right? Where the data is stored in a computer, hard drive, pen drive, anywhere. But where the data is stored in a neural network, I'm talking about the data is stored where? It is stored in the weights, right? How do you say it is stored in the weights? Each input is given a specific value between 0 to 1, right? This is another research area which experts can explore on. Each weight is given a value between 0 and 1 that is unique to that specific input. So you can ask me, 0 to 1 number is seems to be very less. How many data can you store? How many numbers between 0 to 1 are available? Infinite number of numbers are available between 0 and 1. So you can store as many data as you like. Right? So this point is very, very important. Normally people just go to the training algorithm, they use some inbuilt command and proceed. But this is what is very, very important. Now, my research problem 3 is we are going to see some training algorithms. Can you develop some modified architectures and training algorithms? All these research problem 3 and advanced research problem are for only experts. I'm posing you the challenge, right? We can see the conventional architecture and training algorithm, but to use your brain, all these bullet points are important. Try to do some changes and develop your own algorithm. The types of ANN, as previous slides, you can have your inputs and output layer. It is a single layer network. We call it a single layer ANN. Then we have a multi-layer ANN where we have the input layer, output layer, and also we have the hidden layer, right? So what's the difference between these two? Only inputs and outputs are available in single layer, but in multi-layer you have many layers. Types of ANN based on the structure. You can draw the diagram based on the training algorithm. Yesterday, I taught you about the supervised and unsupervised, same concepts, right? So based on this architecture and these training algorithms, our artificial neural networks are classified into many types. I'm giving you only a nutshell, right? But there are many types of artificial neural networks available. But the first point you have to note down is whether it is single layer or a multi-layer network, whether your application suits a single layer or a multi-layer network. Then you go and check whether your application suits a supervised or an unsupervised methodology, right? Only if you find these two things, then you can go into the practical implementation. Supervised means there will be always a guidance. As I told you yesterday, 2 plus 3 are showing a duck and giving the value of duck also through the training or the predictive model. So complete structure of neural networks, different varieties of neural networks, including deep learning, is also there. This you can relaxly look at the video. Only after studying deep learning, you can come here and you can identify what are the symbols corresponds to each thing and how it will be useful for you. So possible applications, biological applications, you can go for modeling, mathematical modeling of different human body parts, environmental, weather prediction. Weather is completely changing nowadays, right? You can analyzing the trends, what will be the goal rate, business, how my business will flourish, what changes should I make in my business setup so my business will flourish, my financial thing, right? Assessing the credit risk or theft prediction in India, right? Or the economical condition of India, how our economy, GDP growth will be there. Everything you can make use of ANN. And I heard, or you can read in newspapers. If you take the Hindu, the last page, every day one application will be there with artificial neural networks. Manufacturing, pencil manufacturing. You may see that your pencil manufacturing seems to be very simple, right? But there also we have ANN, your graphite. That a small black lead should be correctly positioned in the center of the outer structure, right? So for finding the central position also, we go for artificial neural networks. Controlling the production line, quality inspection, medical, right? This is one of the area where ANN is used, widely used, I would say, right? Even the American Association has recently released a methodology for finding a glaucoma with the help of this AN. And glaucoma is an eye disease that can be detected using this AN. And they have released it openly for all the hospitals to make use of it for helping their diagnosis. Surgery, remote monitoring of surgery, prediction, X-rays, MRI, epileptic seizures, Alzheimer, and also in military applications also we have a wide variety of usage of AN, right? For determining the radar signals or determining the position of the mines or that bombs in which the enemy can create some problem for the military. All those things can be thwarted when you go for making use of your prediction with the help of artificial neural networks. So there are also other applications the researchers can say, I am giving you all these things. So if you want to catch up some area and work on, definitely you can come up with some new neural networks for these applications. Face recognition, gesture recognition, gait recognition, walking style, right? Chinese people say when you walk in a different style, they will be able to identify this person is suffering from so and so diseases, right? So that is called as gait recognition. Video surveillance, smart cities nowadays coming everywhere. This video surveillance is important. Speaker identification, virtual reality, right? Whenever you go for virtual reality, the speaker identification is very, very important. Satellite image processing for a change detection or monitoring the climate or earth or forest or the ocean change or the river. All these applications which you be encounter in this world make use of ANN. That's what I told you in the beginning of the last session that ANN is going to rule the world, right? Biometrics. So points to remember, when you start implementation, you have an architecture for your application, right? And also be ready with your training algorithm. 2 points to be taken care when you are ready with your architecture is first identify whether we are going to use a single layer or a multi-layer, right? I am stressing again that single layer will not have any hidden layers. So operation will be taken place only once. Why? No operation will take place in the input layer. That is only for representation purpose. When you go for multi-layer, you can have as many hidden layers as you like. Right? But when you go for your training algorithm, you have to make sure whether it is supervised or unsupervised. If you know already known data with you, then you can go for supervised approach. If you do not have any already known data with you, then you should go for unsupervised approach. Right? So now based on this, I am going to give you two algorithms, right? Back propagation neural network algorithm. These are conventional algorithms. I'm just going to give you an inner view or dimension of that. Next, I will give you some approaches which are modified approaches, right? An advanced level of thinking, how we can change these concepts for the betterment of functionality of artificial neural. Again, why I am giving this algorithm is I have seen many people, they say they may come under the category of intermediate, right? They say we have taken the output and they will show the results. When I ask them the intermediate results, they will not be able to show, right? The reason is when they go for programming, they are using GUI, graphical user interface. In MATLAB it is available. Just choose the algorithms, get the result. Absolutely a wrong idea in research. Maybe it is useful for a or okay for a BTech project. When you come to an MTech or when you come to research, you need to write the code on your own. So maybe I will be showing the codes very soon. For that, these mathematical steps are very, very important. So what is BPN? I have chosen two-layered ANN. Why I am saying a two-layered ANN? Because my operation is not going on inside my first layer, right? I am going to call it as a dumb layer, and only the top two operations are going on inside my hidden layer and output layer. And the training algorithm which we are going to use is gradient descent rule, right? The steps which I'll show you is called as gradient descent rule. What do you mean by gradient? Gradient means derivative or differentiation, right? All these approaches of BPN works on the concept of error, right? I keep on changing my weights. When I come to the output, I give the error back, and based on the error, again I keep on changing the weights. So till my error becomes zero, I'm going to change my weights. But what happens if error becomes constant? If my error becomes constant, it is no longer differentiable. So what I'm going to do is I'm not just going to feed my error back. I'm going to give the differentiated value of my error back to change the weights. That is the only difference, right? This point you have to keep on understanding that, because based on this, we are going to have the deep learning concept. Error is not just feedback. If anyone say you BPN is based on error, BPN is based on error, wrong. BPN is based on the differentiated error value. That's why this approach is called as gradient descent rule, or sometimes it's called as SGD, stochastic gradient descent also, right? And this network corresponds to a supervised training methodology. What do you mean supervised training methodology? You will also give the inputs along with the expected output. That we call it as target. Your expected output, we call it as target. In the diagram, can you see a dotted line from my right hand direction or from the backwards direction? That is called as target, right? Data flow is from left to right, but the target is given in the backwards direction. So this is a structural view, and I have used 8 input layer neurons, right? That means I have 8 inputs. I have used 4 neurons in my output layer. That means I have 4 output classes. In between that, I have 12 neurons. How I chosen 12? Based on some trial and error method, I have fixed as 12. Target is supplied only to the output layer. Note down this point. Why target should be supplied only to the output layer? My question is that. Why can't we give it to the hidden layer? Right? If we think like that, we can create lots and lots of innovative artificial neural networks. I will give you very soon about the innovative approaches. And the target representation is 100. This is for implementation. Practically, if you are going for implementation, when I give an input of Apple, my target, my first layer, I'm predefining it to be Apple. So I give an expect an output value of 1 for that and 00 for the remaining thing. When I give a input of mango to the second neuron or the input layer, I can see that I'm going to give 1 to the second neuron. That means all my output classes are already predefined, right? If I have 4 classes, that means I am going to have 4 varieties of inputs. So I'm going to predefine that, and based on my testing process, I'm going to check whether the same input, different varieties of banana is going to give me the same maximum value at the topmost neuron of my output. And in this architecture, 2 set of weights are there, right? Single layer network is very simple. Why? You have only input layer, output layer. Each link will have only one set of weights, not one weight, one set of weights. Each line will have a different values of 0 to 1. Same thing when you go for the next part, right? You need to have another set of weights. So remember, if you are going for more number of layers, complexity will increase drastically. Understood, right? So we need to make sure that it is not very high, at the same time, not very low. So now we'll go into the algorithm. Before going to algorithm, we need to identify the notations of what we are going to have. As an editor, I could say that most of the research papers I receive in my logging, I see the notations are completely in a chaos. They give some notations in the diagram and some notations are represented in the output, which should be always eliminated, right? Make sure your notations is very correct. X corresponds to input, my Y corresponds to output, T corresponds to the target value, and U is a weight matrix. How many lines I have? 1, 2, 3, 4, 5, 6, 7 or 8 lines I have. That means I have 7 weight values. The same way, we also will have as many number of weight values, right? In this diagram, my architecture is 8 cross 12. So U will be a matrix of size 8 cross 12. B will be having a matrix of size 12 cross 4. So training algorithm of BPN, first we have to initialize the random weights, right? The random weights, I'm going to call it as U and V. So how many weights you will initialize? 8 cross 12 weights for U and 12 cross 4 for V. In MATLAB programming, we have a command called as rand. Using that, you can easily initialize. If you are using any other language, you can make use of other program also. So here I'm specifying the weights as U and V. U corresponds to the parameters ij and b corresponds to the parameters jk. Ij corresponds to the input layer, I corresponds to the input layer, j corresponds to the hidden layer, and the same way k corresponds to the output layer, right? So u is the connection weights between the input layer and the hidden layer. K corresponds to the inputs between the weights between the b corresponds to the weights between the hidden layer and the output layer, right? You have to understand this clearly. U is between input layer and hidden layer, and v is between hidden layer and output layer. For each training input, we are going, when we are supplying some inputs, first we are going to follow a process called as feed forward process, right? What is the first step of a neuron? Net value calculation. So I'm going to find the net value between the inputs and the weights. What is the inputs here? As per the diagram, my inputs are x. What is the weight here? U is the weight. Because it is between I and j, I'm giving as I and j. If I know these two things, I can find the net value, right? My net value of the layer j is given by z underscore I. And now I'm passing it through an activation function, and I'm going to get a layer output, which is I'm going to call it as zj, right? Whenever I use suffix j, it corresponds to the hidden layer outputs or hidden layer net values, right? And now what happens? This output, which output? The output of my previous layer should be carried over to the next layer, right? So Zj will be the input for my next layer. Which layer? The output layer, right? So there I am going to find again the net value. What is the process of net value? Zj into Vjk. What is Vjk? Vjk is the, I'll just show you the diagram. Zj is nothing but the output of my hidden layer, and from the hidden layer I'm going to take my output to the next layer where I'm going to make use of the weights V. So Zj into V will be the process which will be going on inside the output layer, right? And I'm using a function called as sigmoidal activation function. And again, the same process in each neuron, in the hidden layer and in the output layer, same process of net value calculation and output value calculation alone will take place. And when I come to the last stage, I will get my output, which I'm going to call it as yk. Why I'm saying it as k? K corresponds to the output layer. Right? Now this y is my final output. Now based on my output, I am going to find an error. How can I find an error? Right? Already I have a target supplied in my output layer. So if I have my output for my neural network, I am going to subtract y and t, and I'm going to find my error or compute my error. Error is equal to target minus output. If it is zero, can you tell me what happens here? If it is zero, in the first stage itself, if it is zero, what happens? If error is zero, no need to adjust the weights. If there is no adjustment of weights, it means the weight has already stopped or converged. If the weight has already converged, there is no further change in the weights. If there is no further change in the weights, you can say the data is stored in your weights, or your network has learned the data. Understood? Right? So this is the way how you have to derive 10 number of inferences from a single point. Right? So unless otherwise your weight is going to be changed, you are going to continue the training process. Right? So this training process, if your error is not equal to zero, that error will be fed back, right? That error will be fed back, and you can look at the equation number 3. Sorry, not 3. Equation number 4. Don't look at the first three expressions. You can look at equation number 5. Look at equation step 8. Look equation number 5, where we have an expression Vjk new is equal to Vjk old plus del Vjk. What do you understand from this? Theoretically, I can say that a new set of weight value is equal to the previous set of weight values plus some small incremental addition. You know the previous set of weight values, but the question is, what is that incremental addition del Vjk? Understood? So for finding del Vjk, you need to come from step number one, right? The del Vjk is given by an expression alpha into del k into Zj, right? This is a complex derivation which is based on the chain rule, right? If you want, I can give you an offline talk on that, a chain rule of differentiation based expression that. But we look at that alpha, del k, and Zj. I can theoretically put that alpha is called as the learning rate, right? The speed with which a neural network learns. Always its value is going to between 0 and 1, right? 0 means no learning. 1 means full learning. So always when you go for practical implementation, try to have a value between 0 and 1. Between 0 and 1. Alpha is on the one side and Zj is on the other side. What is Zj? Zj is the input for the output layer. Now we are talking about the error process which is coming from the reverse direction, right? So I'm encountering my output layer first. I'm going to change the weights of my output layer first. Only then I go into the changing the weights of my hidden layer. So for my output layer, what is the input? Zj. So always del Vjk will have a value of learning rate alpha and Zj. In between that, we have the error term. What is that error term? Del k is equal to Tk minus Yk. If your method is based only on error, then it is sufficient to have del k is equal to Tk minus Yk. But I told you, it is not based only on the error, it is based on the differentiated value of error. That's why we have the net value differentiation as a second term, right? So based on this, you can find del k. If you can find del k, you can find del Vjk. If you can find del Vjk, you can come to step number 8 and you can find Vjk new. Right? Seems to be slightly complex, but when you sit patiently and look at these expressions, definitely you will come to know. Instead of this, if you go to graphical user interface and click and choose the results, it is of no use for your research career. Now your weight updation is over. Now next weight updation, how can you do that? Now we come to the hidden layer. We are coming from the backwards direction, right? So comes to the next layer of Uij, same expression. Uij new is equal to Uij old plus del Uij. New set of U value is equal to old set of U values plus an incremental addition. What is that incremental addition? Same formula. If you look at expression number 2 and 4, it looks same. Is it not? Right? You have an alpha in the beginning, and in the last you have the inputs. Now, what is the input for my hidden layer? X. So alpha X. In between that, you will have the error term. There, output layer we have del K, but for the hidden layer we have del J. Now, del J is given by Tk minus Yk into some differentiation of its net value. But again, if you look at that, del J in between, in within that, it has del K, right? So del J is not directly related to error. Del J is indirectly related to error. Why? Between hidden layer and your error, you have your output layer, right? Only after passing through the output layer, your error can come and meet your hidden layer. That's why the number of expressions when you go for executing your hidden layer will become 4. If you have more number of layers, mathematical expression will keep on increasing. Only the output layer seems to be simple, Tk minus Yk. But when you go for del J, you will have del K within it. If you go for one more layer, you will have del J within that del K, within that Tk minus Yk. That is the complexity of artificial neural networks. Right? Can we have a parallel architecture by which your error can be parallelly split to all the layers within a step? This is another research problem for expert group people. Right? You can think about that because we need to pass many stages when you come to the first stage. Again, you have to come back next iteration from the previous step. And this process will keep on continuing. And each step you will get Uij and Vjk values. Right? The training stops when the weight correction terms are error equal to 0 or when it reaches the predefined minimum value. This is the simplest training algorithm of back propagation. I can see you smiling there, right? But this is what a researcher has to do on, right? Mathematics is very, very important. Only if you enter programming is very easy. I will show you the program also. That is very easy, but understanding and converting it into a program for the first time is very difficult. Right? Once if you understand these mathematical concepts, not only the expression, why we have this differentiation, why we have del k within del j, if you are able to understand that, then it will be very fine. That's the way how we have to grow. And self-organizing map, I'm skipping that for lack of time. And maybe tomorrow we will be having another section when I go for the case studies application wise and showing some programming codes. At that time, I think I can show you the self-organizing map. But this is also most of the training algorithms are going to work in a similar fashion. I hope you would have understood the concept of BPN, 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 BPN. All the advanced deep learning structures, they have a root either in a direct way or in an indirect way, right? With backpropagation neural network, which is one of the commonly used artificial neural network. So write this expression, see this video again and again and again. Try to ask questions within yourself. Try to answer. Put some mathematical calculations in the notebook. Definitely, you will become an expert in backpropagation neural network. Then you come to. So this is almost time. Now I'm giving you an assignment for this day. Thank you very much. The last session I have received some overwhelming assignments. Some of you have given send the information to my WhatsApp group also. Thank you very much. But I think the coordinator is having a separate folder, some sort of for collecting the assignments. Please submit to her from where I can collect the assignments. Right. So today's assignment will be two algorithms. Right. How I have taught you BPN. You go and check perceptron training algorithm. You can Google or from any other books where you can find the mathematical steps. Write the mathematical steps, understand my video, right? Then you go and write a theoretical summarization of it. I do not want your algorithm, it is already in the book. I want your theoretical explanation. Then I can understand how much you have grasped from today's session. Same way, there is another algorithm called as counter propagation. These are simplest algorithms. That's why I'm giving to you so that you can go for that. Any queries? I would say that please come to StreamYard and check your ask your query so that when you post that, I cannot understand in what way you are asking your question. So it will be always better if possible. You can come and ask your queries in StreamYard. If not, Madam will be taking your queries from the chat and she will ask me. Thank you very much for your patience listening. So today's session, theory plus mathematics. I want you to put some concentration on this concept of mathematics. Thank you very much for your patience listening. We're ready for the question answer session.
Hello, sir.
Madam, any queries?
So one question I
Yeah.
received from the participants: what happen if the learning rate is taken as the value
Okay.
0?
If
What?
the learning rate is taken as 0, can I show that expression once again? I don't know whether you can see that. If the learning rate is taken as 0, your expression number. Madam, can I share the screen once again?
Once again, okay, sir. You can share,
Is
sir.
my screen visible?
No, sir.
It is there?
No, no. And now it is visible.
Now it is visible?
Yes, sir. Yes, sir.
Hello?
Yeah,
Okay.
yes, sir.
Now the question, the answer I can give you. Now you look at numbers, equation number two, right? The second equation and the fourth equation. You have a learning rate. I told you alpha. If you substitute zero there, right? If you take alpha is equal to zero, right? What will happen? Alpha into del k into zj will automatically become zero. That means del bjk will become zero. Del uij will become zero. So when you go for step number 8, Vjk new is equal to Vjk old plus 0. That means Vjk new is equal to Vjk old. There is no change in the weights. That means there is no training. In other words, there is no learning. Your network has not learned at all. So alpha should not be fixed as 0.
Second question, sir. Hello.
Yes, madam.
Second question. Sir, can you please repeat gradient descent rule?
Okay. Gradient descent rule, right? This is one of the commonly used rule where BPN depends upon the functional principle of gradient descent, right? Gradient descent, this term, this sentence or this phrase, I would say, has two parameters within that, gradient and descent. Gradient is one concept, descent is another concept, right? Descent, first we will see about descent. What do you mean descent? Ascent, descent. Descent means decreasing. Something is moving in the negative direction, or something is moving from a higher value to a lower value. What is that in our application? In our application, it is error, right? Initially, when the during the first state of iteration, my error will be always high. I said that what happens if error is equal to zero, but 100% of the time you will not get error is equal to zero in the first step, right? So error will not be zero, but error will be high. So when the next step, based on the error, you are going to adjust your weights. When you adjust your weights, when you adjust your weights, my net value changes, my output value changes. Now my after my output value changes, when I go for my calculating my error, again my error will change. I am saying changing, right? But I am on the hope that my error will decrease, because my objective is only if I bring my error lower to zero. When my tk minus yk is zero in my first expression, del k will become zero. Am I right? When del k becomes zero, del vjk will become 0, right? When del vjk becomes 0, my del j will become 0 and the learning stops. So in order to make sure that my error is equal to 0, I am doing all this training process. So that's why descent, my error is going to decrease. But the problem is my error will be always a function, right? It will be always a function because I have an activation function differentiation along with my normal error value. If this function is there, it is easily reducible to 0. But when it comes and stuck in a constant value, right? After that, it cannot move or it cannot come to 0. But a constant value differentiation, what is differentiation of phi? 0. That's why we do not use integration. Integration of phi is not equal to 0. Only to make sure that your error should be at least come to a lower level, we include the concept of gradient or differentiation. Differentiation has the capability of bringing any constant value to 0. That's why we say that this algorithm, because error should be made equal to 0, and also it depends upon your differentiation, we call this as gradient descent algorithm. But this gradient descent is not only for BPN, it's a common signal processing approach, right? Random search or search approach. But we make use of that for BPN, or the scientists who framed this made use of this stochastic gradient or gradient descent. Did I answer you?
Yes, yes. Sir, one more question, sir.
Okay.
Sir, I'm doing research on social issues here. How can I manage, how can I decide on
Okay.
weight to each input parameter? Because every factor has varied importance in my decision.
mm, social issues. When I
Yes.
see that social issues, it seems to be very broad to me. What do you mean by? I want to know what is that social issues. Is it whatever may be your application? It must have a data within it, right? Ma'am, can you read that question once again?
Okay, sir. I'm doing research on social issue. How can I decide on weights to each input parameter? Because every factor has varied important in my decision. Every factor is varying in my
Yeah,
decision.
that's correct. That's what I told you, right? Whatever may be your application, you will not know the importance in the initial stage, right? If you know the importance in the initial stage, then there is no necessity for training, right? Which input is important or how you are going to make a correct your correct decision, right? It is based on the importance of your weights, because each input has different say on your decision making. The weight value for each inputs will be different, but we do not know that, right? But when you go for using this back propagation neural network algorithm, finally you will get a correct weight for each of your data or inputs. Then your system will give you an excellent decision making, or the decision will be accurate. Right? You are correct, right? You will not know the importance in the initial stage, but only after training the process, looking at the experimental output, you can check that whether your weight values are correct or not. If you have someone to validate your results, then it will be well and good. Otherwise, you can easily find out if you are getting a results as per your expected output, then the weight values are going to be matched.
Yes, the next question. How do we decide the number of layers in any artificial neural network?
Yeah, that's what I told you. I gave it as a research problem to you people, right? Um, Input layer you should have, output layer you should have, right? There is no change in that. VPN, right? VPN works in a poor manner when the number of hidden layers are increased to a significant level, maybe beyond five, you can say, right? That's why deep learning came into the picture. The same architecture of VPN is used in deep learning, but the only thing is the algorithm is different. That is different case which I will deal with you in the next sessions. Right? But for the time being, if you want to use VPN, I would advise you based on my experiences, don't go beyond two. Even one may be sufficient if your training algorithm is very good, right? But don't go beyond two. If you go beyond two, it is going to again, it is not linear. If you increase the number of layers, you will get a good result. It's not like that, right? It's non-linear. So there's a chance that your results may quality may come down. Or other words, you can do a trial and error method, right? You first set two, then set three, then set four, and then check, right? Mostly I may think that one or two hidden layers would be sufficient for simple applications. If you want to go for increasing the number of layers, go to deep learning.
Next question is why we are taking sigmoid function.
Sigmoidal function can be also replaced, right? Any function, any activation function can be used. One general function is normalization function, right? But sigmoidal function has a capability of giving an output soon, right? BPN already has suffers from computational complexity. One of the drawback of BPN is the execution time. It will take a longer time. But if you want to replace sigmoidal with another function, then that will be also good, right? But there is no standard reason why we go for this. Any functions can be used. Mostly people go for sigmoidal activation functions because the standard structure of BPN is with sigmoidal activation function. This is called as S curve. They call it as S curve. Your waveform will increase and slowly it will decrease and come to the dynamic range. So there is nothing wrong. That I have seen some BPN approaches. BPN is also called as multi feed forward networks, where people have replaced sigmoidal with other functions also. But whether you will get good quality result for changing that, that is again debatable.
The next question, can we have only feed forward network without back propagation to do classification of images?
Madam, can you repeat that once again?
Can we have only feed forward network without back propagation to do classification of images?
Can we have only feed forward network um, for classification of images? Self-organizing map you can use. I have not given that. There is no feed back, not feedback. The error is not sent back in the reverse direction, but that is used for clustering. But you can do some post processing and you can use for classification. Right? Last class I showed the images of ducks. It will not say that it is a duck, but will categorize into a specific group. From that, you can have a post processing and have a classified approach. There are other neural networks also. Hopfield is there, but Hopfield is a recurrent neural network. Then we have radial basis function neural networks. We have perceptron networks, right? There are many networks, but each one of them have their own drawbacks and merits, right? So yes, the answer for your question is yes, there are approaches where you can find or do classification without the back propagation of. I think you are scared of the mathematical equations when the error is propagated in the backwards direction, but bpn gives an excellent output. If you want to test your application, it is one of the best choice I would recommend.
So next one is what is meant by error in the point of image or raw data?
Error in artificial neural networks will not consider whether it is an image or a signal or any other text. For human beings, it looks like an image, it looks like a signal, it looks like a data, right? But for a computer, it looks or it understands only numbers, right? It takes only numbers. That means I will show in the next application. Your analog data will be converted into numbers. Computer is always a hard-hearted fellow. He's not kind-hearted like us, right? So all the data will be converted into numbers, and it will understand only numbers. When you have numbers, y will be a number, t will be a number. Then automatically error will be also a number. So computer will not check whether it's an image or a signal. It is the user, it is the programmer who is going to interpret that output as whether it is going to be a image or a signal or a text.
And one of the participant have requested in the FDP one day, can you please explain about the pre-processing segmentation, feature extraction, classification with an algorithm that will help for his project?
Uh, Yeah, I think you have a good prediction skill. That is the actual agenda of tomorrow's session. I do not know how you got this or from where you got these details, right? Thank you very much. Tomorrow I'll be, so that's why I'm going in a simple flow. First day I have gone for only the basic understanding, right? Today I have taught you only the mathematical steps of algorithm, and tomorrow I am having a feeling of giving that algorithm for a practical application along with explaining the codes, but I need some more time for that. So mostly I will be giving an application and code. Epochs.
Hello. Okay, sir.
Yeah, tell
Thank.
me.
That's all, sir. The questions are
One
over.
epoch,
Hello, sir.
one epoch is equal to one feed forward plus one BPN, right? Yes. When you say one epoch, it completes right from the first step till the last step, right? Calculating the error and then coming back. That is called as one iteration. When you say second iteration, a new set of weight values will be there. They will be going again from the first till the last, and then from the last till the first. Going front, coming back. This is one epoch.
And one more question for brain tumor classification. Which one is better, supervised or unsupervised?
Unsupervised networks normally gives better accurate results than your unsupervised architecture, right? So when you go for brain image classification, accuracy is very, very important. It's a life or death problem. You cannot just take risk and say that this patient is not suffering from or is not suffering from that, right? So accuracy is very important. When you say your application needs accuracy, you should go for some supervised approaches only. right? There are some applications like scene classifications, video picture surveillance, for which the clarity of the data is not that much important. In that case, you can go for unsupervised classification approaches, right? Even if you miss a symbol or a single tumor pixel in your image, that is going to grow, right? So you need to be accurate. For accuracy, you should go for supervised training methodology.
Next question, sir. How to give target to output layer? Please clarify in terms of real-time models.
In terms of real-time models, when you go for programming, I think when you talk about programming, it is only when you talk about real-time models, it is about only programming, right? I am not talking about the just fixing the parts. I'm talking about the programming part, right? In the programming part, when you are giving the targets, right? If you are having three classes, it should be three different numbers, right? If you have three classes, you have three output neurons, and each neuron is assigned to a class. That means when I give one specific category, say for example, apple, if my first neuron is assigned or predefined to that apple, there is no physical assignment. In your heart, in your mind, you have virtual assignment. If you feel that apple is for the first class, then that neuron's output, right? I told you why. That neuron's output should give a maximum value of 1. Or if not 1, it should give zero point 0.9 or zero point 0.8. The other two values are normally set to 0 so that to show that this output belongs to, sorry, this input belongs to category number 1. So when you look at the final output, the first neuron's output will be zero point 0.9. The second neuron's output will be zero point 0.05. The third neuron's output will be zero point 0.05. Then you will understand that the banana belongs to the first category. So when you show an unknown image in the testing process, neural network can easily categorize it into the first one. 100. That is the best way of representing the target vector to avoid any confusion. People also assign 1, 2, 3, and many other values, but that may need some post processing. So it's always good if you go for 100 method of assignment. The next one will have 010, and the third one will have 001.
And last question, sir. Can we use artificial neural
Hmm.
network for text mining?
Can you tell me?
Can we use artificial neural
Text
network?
mining, artificial neural networks for text mining. I have not actually worked in text mining, but text mining is an application from where you can collect lots and lots of data from a single um, text or an sentence, right? For that, there may not be much use of artificial neural networks. That's what my opinion, right? Artificial networks is mostly used for prediction, right? But text mining, I'm not sure how much prediction you have in text mining applications. If you can relate prediction with the text mining application, then definitely you can go for artificial neural networks.
So one more question also came. Is there any possibility of
Yeah, yeah,
adding?
please, please.
Is there any possibility of adding previous history in the classification of digital mammograms?
Previous history. Digital mammograms is in the form of an image, right? If you want to add the previous history, that means you may talk about an image which we have already taken. I'm not sure what you mean by previous history. If you have taken already an image, you can go for image fusion, right? There are many fusion applications where you can fuse an image, what you have taken now or what you have taken some months back. That you can fuse and you can go for giving an fused output. In that way, you can mix your previous historical data. Or if you have some text data, patient's diabetes or other things, that also can be fused using some watermarking or any other approaches are also available. But my question is, what is the necessity for that? If you are able to identify, if you are able to identify your disease within your mammogram, What is the necessity for your thing like family history, number of ham? That's what I'm asking. You can incorporate that within your mammogram images, but will that additional data is required for decision making? Can't we take a decision accurately within that image alone, right? Your cancer cells um, may be visible within the mammogram image itself. If we are able to identify that, then it is going to we are going to say that this patient is suffering from cancer. Right? There is segmentation where you can segment all the cancer pixels, right, and say that whether your treatment is in the positive stage or negative stage. You can do that, but I don't find any specific necessity for mixing your family history and other data with your images. Not very sure how it is going to help you, but you can experiment it.
So that's all, sir. Um, Thank you so much
Okay.
for your informative and fruitful session. You have explained the basics of ANN and the steps of algorithm very clearly for the participants and the beginners. All the participants were benefited by your session. We are eagerly waiting for your session tomorrow. Once again, thank you, sir.
Thank you very much. The beauty is most of you has joined in the second day also, right? Please continue to learn. Try to do the assignments in a perfect way. So that is the way how you can learn. I have given my email ID in the last link. If you have any specific queries, right? When you write something in text, I may not be able to understand what is there in your mind exactly, right? So if you want to have a chat or any specific thing, you can always contact me at any point of time. We will meet you tomorrow also, same time. Thank you very much.
Thank you, sir. Participants, there is no feedback form. Feedback form I will give you on 31st. And assignment link, I put it in the chat box. I will also put it in WhatsApp group also. So thank you for your participation. We'll see you tomorrow.